Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have k times square root of k is equals to 64 and we solve this problem for all the values of k. Here first we find all the roots of this equation and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. And now we move towards the solution of this problem. So here the very first step we are going to do is first we need to remove the radical sign from left hand side, and for this we will take a squaring on both of the sides, and this will becomes k times square root of k whole square is equals to 64 and its whole square. And now further in the next step, we just apply the square separately on both of these two values, and we will get here k square times square root of k whole square is equals to, we write the 64 as 4 cubed and its whole square. And now further in the next step we need more simplifications here, and we get k square times this 2 and this square root are gone, and we get k is equals to, here in the right hand side we just interchange both of these two exponents and we write it as 4 square and its whole cubed. And further in the next step we have k square times k is equals to k cubed, and here you see that 4 square becomes 16 and its whole cubed. And now in the next step we just move the term 16 cubed from right hand side to the left hand side. So this will be written as k cubed minus 16 cubed, and this whole equation is equals to 0. So here we apply the nice cubic formula. You know about that. If we have a cubed minus b cubed equals to a minus b times of a square plus ab plus b square. And you see that the base of this term is our a and the base of this term is our b. So we apply here the cubic formula into the left hand side, and this will be written as k minus 16 times of k square plus k times of 16 plus 16 square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write a k minus 16 is equals to 0, and the second case is we write k square plus 16k plus this is 16 square, and this whole equation is equals to 0. From this case, we easily get the value of k is equals to 16. This is the first root of the given equation. And here you see that this is the quadratic equation, and we know about that there are three methods to solve the quadratic equation. So the first method is the factorization method, second one is by applying the quadratic, second one with the completing square, and third one is by applying the quadratic formula. So here we use the quadratic formula to solve this quadratic equation, and for this first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 16, and c is equals to 16 square. And we state the quadratic formula as k equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. So this is our quadratic formula, and here we substitute all the values of a, b and c, and we get k is equals to, this is minus b, the value of b is minus 16 plus minus square root of b square. It will become 16 square minus 4 times of a is 1, and c is 16 square and it is divided by 2 times of a, and here our a is equals to 1. And now further in the next step we need more simplifications here, and we get k is equals to minus 16 plus minus square root of, you see that inside the square root sign we have 16 square with the common value. So we take common 16 square from here, and we get the remaining values are 1 minus 4, and it is divided by 2 times of 1 equals to 2. And now further in the next step we need more simplifications here, and we get k is equals to minus 16 plus minus, here we apply square root separately on both of these two values, and we get square root of 16 square into 1 minus 4, and 1 minus 4 becomes minus 3, and it is divided by 2. And now further in the next step, we need a more simplifications here, and we get from here k is equals to, this is minus 16 plus minus this 2 and square root are gone, and we get 16 into, this is square root of minus 3. We know that when negative sign appears inside the square root sign, it will becomes iota. And further we break this fraction and we write these two separately on both of these two values, and we need to cancel these terms. We have 2 8 the 16 and again 2 8 the 16, so we get the values of k is equals to, this is minus k minus 8 plus minus 8 times of square root of 3 into iota. So these are the two complex roots of the given equation, and finally we have, there are three roots of the given equation, in which the first root is the real root, that is k1 is equals to 16. The second root is complex root, it is minus 8 plus 8 times of square root of 3 iota, and the third root is k3 and it is equals to minus 8 times of square root of 3 into iota. These are the three final roots of the given equation, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.